Well, hey, welcome back. It's Monday. Well, not for me. Right now it's Thursday for me. I'm making videos and doing parent-teacher conferences. But for you, watching the video, it's Monday. I hope my weekend was good. Hope yours was too. All right, so today we're going to talk about something called differentiable. Essentially, what that word means is that we want to know if the derivative exists. All right, so to do that, we have to review word continuous. Remember, continuous graphs have no holes or vertical asymptotes. So if something is differentiable if, again, the derivative exists at all values of x in the domain. So essentially, the graph has to be continuous. That's the first part. All right, but if it's continuous, it doesn't necessarily mean that it's differentiable. And to know that, you'll have to revert back to your notes that you were supposed to read before you watch this video. So if you've started the video without reading the notes, now would be a good time to pause, go back and look at the notes, then come back and continue the video. All right, so when it comes to differentiable and continuous together, if something is differentiable, then it is absolutely always also continuous. But the reverse is not necessarily true, and we're going to look at some examples in a minute. If a graph is continuous, that does not necessarily make it differentiable. And again, differentiable means that it has an actual slope of a tangent line that's an actual number. So let's take a look. All right, it says, is the graph continuous, differentiable, neither, or both? All right, so let's take a look at this first one on the left, top left. We'll call it number 1. All right, so first off, let's decide if it's continuous. So if it's continuous, it means that it doesn't have any holes and it doesn't have any vertical asymptotes. So I would say yes, this one is continuous. Now, is it also differentiable? Well, if a graph is continuous, then there are three things that could make it not differentiable. I can't speak very well tonight for some reason. So again, there are 3 things that make it not differentiable. One of them is if at a point there is a corner. All right, that's definitely one of the reasons that we would have something be not differentiable, is if it's at a corner. All right. Now, another reason that it would not be differentiable is if it has a vertical tangent line. I mean, a tangent line that goes straight up and down, complete verticality. And then the last reason that something would be continuous but not differentiable is if it has a little kind of like a corner, but it's not called a corner, it's called a cusp. It's kind of weird, but again, that was all in the notes that you were supposed to read beforehand. So let's look at number 1. Is it differentiable? So again, we're looking for 3 possible weird things. The first weird thing is, does it have a corner like it makes a V? And I'd say nope, that one doesn't do that. Second thing, does it have a cusp? A cusp is kind of like, a little kid drawing a picture of a bird flying in the sky. That little corner point that's not really a corner, but kind of like a corner. So, no, doesn't have that either. Then the other thing we'd be looking for is a place where the tangent line would be vertical. And that's kind of hard to think about. And we'll see one in a minute that is a vertical tangent line, but this one does not have it. So that means it is continuous and differentiable. So my answer then would be both. It's both. All right, let's try number 2. First off, is it continuous? So again, I'm looking for holes or vertical asymptotes. Don't have any, so yes, it's continuous. Now let's check to see if it's differentiable. All right, so again, 3 things I'm really looking for. Does it have that corner like a V or like a cusp? Does it have one of those? The answer is no, so it's okay. The other thing I'm looking for is a vertical tangent line, and this one has it. This one has a vertical tangent line. Basically, it's a place where the graph kind of gets stretched out almost where it's vertical itself. So again, if you kind of look in this spot right here, it's almost like the graph is going straight up and down for a little section. That means it is not differentiable. There will be a spot in here where, again, the tangent line has an undefined slope. So it's not differentiable at that spot. This one is just continuous. That's it. All right. If I take this one in the bottom left, what I'm calling number 3, first thing I want to look at is see if it's continuous. So it can't have any holes or, this one's got holes right there. So this one is not continuous. All right, now to be differentiable, it has to first be continuous. So since it's not continuous, it's also not differentiable. This would be a neither. Has to be continuous to be differentiable across the whole graph. All right, now the last one, let's call it number 4. So again, first thing I'm looking for is it continuous. So I'm looking for holes or vertical asymptotes. Everything looks good there, so this one will be continuous. And then I'm looking for differentiable. Again, the things I can't have a corner or a cusp. And I got it right there, I got a corner, which means, again, not differentiable. This one would just be continuous. So a little confusing, but everything's going to be a little confusing this year because it's all new information. It's no repeat. We're not covering something you already learned in Algebra 2. Every little detail from here the rest of the year is going to be brand new information. Even if it's not hard, it's confusing at first. All right, so we're going to spend a whole couple of days on this idea of differentiable. All right, good luck today. Let me know if you need any help.